This video recording is for Algebra 1, Chapter 2, Lesson 4. It's a very long lesson, so I'm going to go ahead and skip the video for today. First, some vocabulary. Ratio. A ratio is a comparison of two numbers by division, and there's three different ways you can write it. You can write it as a number to a number colon a number, and a number divided by a number as a fraction. And it should probably look like this, a over b, right? Because most of you guys are used to looking at a fraction like that instead of like that. Yeah, okay. A rate is a ratio where the two numbers are different units. And an example of that would be down here, where I've got money compared to roses. Money compared to roses, where money is one unit and roses is the second unit, okay? So a unit rate is a rate, so, usually with different units, right? Different units where the denominator is 1. An example would be 40 miles per 1 hour or 40 miles per hour, all right? All right, so here's an example problem. We have Main Street florist sells 2 dozen roses for $24.60, and Fresh Flowers sells 6 roses for $7.50. So they want to know, find the unit rate for each. So basically, they're asking how much does one rose cost, because they're not going to sell you like 1.5 roses, even if 1.5 roses cost $1. It's easier to get the price compared to one rose as opposed to $1 compared to a rose that you may have had to cut in half. And no one wants a rose that's cut in half, or at least to pay for a rose that's cut in half. All right, so which florist has the lowest cost per rose? So to do this, we're going to divide. We're going to divide the cost of the amount of roses you get based on the price they're giving you to get how much each rose costs. So I'm going to take $24.60 and divide it by 24, and that's going to give me $1. And it's actually 3 cents, because if you do the math, you're going to get 1.025. And since we're dealing with money, we have to have only two numbers after the decimal point. So it's $1.03 per rose when we're dealing with the Main Street florist. Well, now let's talk about the Fresh Flowers florist, which is the FFF over here. Well, if they sell you 6 roses for $7.50, we're going to divide $7.50 by 6. And you're going to get $1.25 per rose. So which rose price is cheaper? Well, that's going to be the Main Street florist, because they're only charging us $1.03 per rose, whereas the Fresh Flowers is charging us $1.25 per rose. All right, next problem. Oh, I'm showing you too much, but that's okay. All right, so here's the problem. Distance, rate, time. You're going to see a lot more of this later on in the chapter, especially when we get to the next lesson. It's all about distance, rate, and time. It's going to be insane. You're going to hate it, but we'll wait for that until a little later. For right now, let's just do some simple distance problems. Suppose you walk 2 miles in 40 minutes. Find the average speed and write an equation. All right? So, I put the 40 minutes over 2 miles just because it might simplify a little easier. If I wanted to see how many minutes it takes me to walk 1 mile, which would be the unit rate, I'm going to divide them, and 40 divided by 2 is 20. So it takes me, oops, I did it again. It takes me 20 minutes to walk 1 mile, right? Because nope, I changed it. So it's 2 miles over 40 minutes, and so if we're going to divide, it's going to end up being 1 mile over 20 minutes, because it takes me 20 minutes to walk a mile. So if I multiply this now by 3, because there are 60 minutes in an hour, and I kind of wanted to get to 60, so 20 times 3 is 60, and 1 times 3, or 1 mile times 3, is 3 miles per hour, right? So now the second question, part B, is how many miles can I walk in 75 minutes? Well, I'm going to go ahead and set up a proportion, because we're going to talk more about proportions in just a second. So I want to talk about proportions now as well. If I say that I can walk 3 miles in 60 minutes, but I want to know how many miles I can walk in 75 minutes, I'm going to set them equal to each other so that miles are on top and minutes are on the bottom. And you want to keep your units consistent like that. Your units that are the same should always be very close to each other, or like all on the top, or all on the bottom, or all on the right, or all on the left. Okay? So then I'm going to do the cross product. So this times this, which is 60 minutes times unknown miles, equals 3 miles times 75 minutes. And so I'm going to set that up as 3 times 75 is equal to x times 60, since I don't know. That's basically x, right? X miles. So we use a variable since we don't know what it actually is. So now we're going to go ahead and simplify. I'm going to do 75 times 3, which is 225, is equal to 60 times x. How do I get x by itself? Divide by 60. Divide by 60. 225 divided by 60 is 3.75. And what was the thing that we were looking for? X equals 3.75. Well, what was x? X was miles, and miles that we can walk in 75 minutes. So we can walk 3.7 miles, or 3 3/4 miles, in 75 minutes. Okay? All right. So this is just asking you questions about stuff. All right. Next thing we need to talk about is unit analysis. In my opinion, this is also known as AKA dimensional analysis. And I think this happens to be like an algebra student's worst nightmare. Really, I only learned it because of chemistry. It's very useful in chemistry, and it's going to be very useful in other sciences, but I know it really throws a lot of you guys for a loop. Okay, so unit analysis, also known as dimensional analysis, use conversion factors. Factor sounds like multiplying fractions, which you're going to be doing, or ratios that equal 1. Remember, ratios are things that are compared using division. A fraction is an example of a ratio. And we're going to use these things to convert units from one set of units to another set of units. So we're going to be going from like feet per second to miles per hour. Okay, and that's actually the next example I have, so I spoiled it. All right, so very similar to simplifying fractions, which allow you to cancel out units. So let's go look at an example problem. And the example problem is about a cheetah. So a cheetah runs 300 feet in 2.92 seconds, and we want to know what the cheetah's speed is in miles per hour. So a lot of information we need to use is things that equal each other. We know that 5,280 feet is equal to a mile, and we know that there are 60 seconds in a minute and 60 minutes in an hour. So the first thing I'm going to do is convert my feet into miles. So if I've got 5,800 feet, that is the same as 1 mile. Okay, it's the exact same distance. So what I'm basically doing is multiplying by 1. Now, the reason that I set it up exactly like this is because I want feet to cancel out. If I have feet over feet, that equals 1, and they basically just cancel out. So now that I'm multiplying fractions, having a foot on the top and a foot on the bottom means they cancel out. So I'm no longer dealing with feet, I'm now dealing with miles. Okay? Now I need to do the same for the seconds. I want to get to hours eventually, but I need to get there. And you can do the quick way if you just happen to know how many seconds are in an hour, but I'm going to go ahead and do it the long way so you can see it the long way. Okay, so I need my seconds to cancel out, and to cancel out seconds, I need a second on the top and seconds on the bottom. Since I already have seconds on the bottom, I'm going to go ahead and put 60 seconds on top. Well, 60 seconds is the same as 1 minute. Now that I've got seconds on the bottom and on the top, they cancel out, and I'm now at miles per minute. But I don't want miles per minute, I want miles per hour, because that's what they're asking us for, miles per hour. So now I need to convert minutes into hours. Well, since I've got a minute on the bottom and I need to cancel out, I need to put a minute on the top. It's actually not 1 minute because I need to get to hours. So it's 60 minutes is equal to 1 hour. All right, now that I've got minutes on the bottom and the top, they cancel out, and I'm now officially at miles per hour, right? Because the minutes canceled out. And it actually comes out very well. You should have, actually that's way too dark, you should have the top and the bottom the same as the first and the last. the miles over hours, miles per hour, and you will end up with that in the same way, and that's one of the ways you'll know you're correct. Now that I've done all of this work, what's the last thing I need to do? Well, I need to multiply fractions. I've got a fraction times a fraction times a fraction times a fraction. I have 4 fractions. But what you can just do is do what you normally do when you're multiplying fractions, which is multiply the top. So that's 300 times 1 times 60 times 60, which you've got a calculator, so it should go pretty quick, times 2.92 times 5,280 times 1 times 1. All right, so you got a calculator. Go ahead and do it. 300 times 1 times 60 times 60 is a huge number, 1088, and then 4 zeros. Okay, and then I've also got 2.92 times 55280 times 1 is going to give me a kind of big number too. 417.6, and now I need to divide. So I'm going to divide the top number by the bottom number, and I'm going to get 70.0498 blah 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 blah. But roughly I'm just going to round. So how fast can the cheetah run? Well, the cheetah can run about 70 miles per hour. That's pretty fast. That's breaking the speed limit in some areas. Okay, so we still have one more thing to talk about after this, so I'm going to just keep on rolling, okay, guys? If you need help with this, definitely ask. I completely understand if this is difficult, but make sure that you're able to cancel out by having the units that are the same, one on the top and one on the bottom, okay? All right, last thing we need to talk about is cross product. This should be review, but of course, Algebra 1 makes review and then makes review harder. So let's go ahead and talk about it real quick. So I'm sorry this video is long. It's a good thing it's over the weekend, huh? At least I'm filming this on a Friday. Okay, so when you're doing cross product, when you're doing a proportion, proportions are equal to each other. And we can figure out a variable by saying that things that are diagonal from each other equal each other when multiplying. That would be cross product, because product means multiplication. So what I'm going to do is I'm going to say that 4 times 25 is equal to 12 times x. And then I'm just going to go ahead and solve for x. 4 times 25 is 100, equals 12 times x, divide by 12, divide by 12. 100 divided by 12 is, 100 divided by 12 is 8.33, which is the same as 1/3. Equals x. So that's what x equals. That is, if we replace x with 8 1/3, we're going to get a true statement. Okay? Alright, so let's go ahead and do the next one. The next one's got some really funky stuff going on. So let's go ahead and take a look at it. So we have 10 times x plus 2 is equal to 14 times x. Well, we need to go through and do the distributive properties. So it's going to be 10 times x plus 10 times 2. 10x plus 20 is equal to 14x. I'm going to minus 10x minus 10x. And 20 is equal to 4x. Divide by 4, divide by 4. X equals 5. All right, so if I plug in 5 up here, I'm going to get 5 plus 2 is 7. 7 divided by 14, well, that's a half. And if I plug in 5 here, 5 over 10 is also a half. So that's how we know that we got it right, because the ratios are equal. All right, so one more example problem. It's going to be very similar to number 2. So I'm just going to go ahead and do it, but I won't talk through it as much. So it's going to be 3 times w minus 4 is equal to 5 times w plus 6. Distributive property. And I already went ahead and added the opposite. And I need to combine like terms. So that's going to be 2w is equal to negative 42 divided by 2 divided by 2. W equals negative 21. All right, and again, if you plug it back into W, you're going to get the right answer. All right, so sorry this was long, but it's a long lesson. All right, see you guys later. Bye.